When designing fiberglass-reinforced plastic, or FRP bridges, engineers often have to rely on theoretical data. To prove the performance of its FRP pedestrian bridges with full-scale test data, Bedford asked the University of West Virginia to conduct the first-ever real-world test of a 100-foot by 10-foot bridge suitable for a single emergency H5 vehicle. While coupon-level testing is common, full-scale bridge system testing at this length is unprecedented.
After the design was completed, the bridge was fabricated and assembled here at the university's grounds and full-scale tested with the same loads that we had used in our analysis. There has never been a test such as the one that we are experiencing or witnessing today, in the sense that a full-scale bridge such as this has never been built to its actual size and tested with the actual loads that the bridge would experience.
The top things that we are looking to test in the bridge are deflection, which we get from its own load. It's the first test that we perform. And after that, we apply some additional load to match the loading requirements on the bridge. That will give us what we call the live load testing. We also measure deflection under those conditions. Additionally, we do some lateral load testing. We pull the bridge on a side in order to simulate the condition of the wind going through the bridge. We also perform a vibration test, what we call a drop test, on which we try to measure the natural frequency of vibration on the bridge.
To simulate an H5 vehicle, the university loaded a 5,790-pound U-Haul truck with 4,000 pounds of sandbags. This vehicle load capacity test proved that Bedford FRP pedestrian bridges can not only support hikers and bicycle traffic, but can also safely support a single emergency vehicle in the event that a rescue is needed. Under a uniformly distributed live load of 70 psf, an instantaneous deflection test showed a vertical deflection of just 3.27 inches, well under the engineering maximum vertical deflection requirements for a heavy crowd.
The bridge behaved exactly like we predicted it to behave. It performed extremely well under the vehicular load and under the live load of 70 psf.
One of the benefits of an FRP bridge is that its lightweight materials are easy to transport and install. To show that the lightweight is no cause for concern under heavy winds, a lateral force resistance test was conducted. The bridge withstood a 10,000-pound sideways pull, simulating the push of extreme winds of 120 miles per hour, representing a rare 700-year storm event. The test resulted in a transverse deflection of only 5.39 inches. The tests also show that engineers can count on their FRP bridge to last for decades. Bedford pre-stresses materials prior to installation, ensuring high camber performance. Under a 70 psf uniformly distributed live load monitored for 5 days, the maximum creep deflection was 0.55 inches. This data shows that Bedford's assembly method keeps the bridge level and looking new for its entire lifespan.
At Bedford, we believe that it's very important to certify that the products that we're putting out there are safe for use for the public. A bridge or a structure of this characteristic usually is a big investment, and we want to guarantee that the corporations and people and associations getting into one of these investments, that they're making good use of their money.
Just as important as the durability is making sure that people feel safe and comfortable crossing the bridge. During the tests, the bridge recorded a transverse frequency of 3.69 Hz, exceeding the standard for comfortable bounciness or vibration. The strain measurements recorded during the tests showed that the bridge had the required strength to perform well when subjected to the tested live loads. The maximum recorded strain was only -995 microstrain, which is 25% of the total bridge capacity.
Full-scale testing is required in order to guarantee that the structure is going to behave like we designed it. to behave. We needed to guarantee that the results we're getting in a computer analysis are going to be the same in real life. That's why full-scale testing is required on this type of structures.
When clients witness a full-scale test such as this, they have additional confidence that the bridge that is being supplied by Bedford and the bridge that they are going to buy will perform in the way that they expect it to perform.
To learn more about Bedford FRP pedestrian, equestrian, and golf course bridges, visit bedfordreinforced.com.